everyone, and welcome to the McMaster AI Society's tutorial on classifying your music with the Random Ofrest Classifier. Today, you'll be training your own machine learning algorithm, what different genres sound like. And your algorithm from there will be able to tell what genre new music that it hears is. So let's say we told our classifier what classical music and hip hop music sound like. Getting an album from Kendrick Lamar, it'll say, aha, this is a hip hop song. And we'll be able to teach it to do just that. And then finally, you'll be able to use your machine learning algorithm on your own playlist and see what your playlist sounds like to your algorithm. So this is the outline for today. We'll be importing our libraries and setting up the API. Then you'll get your data set. After that, we'll train the Random Ofrest Classifier on your data set. We'll see how it performs. And finally, you'll be able to use your algorithm on your playlist. The libraries we'll be using are as follows. We have Spotify, which gets data from Spotify's servers. It's a Python library. Next, we have Pandas, and Pandas is a library for storing and manipulating data tables, which are called data frames. This makes it very easy to take a look at your data in very neat tables. It'll be easy to manipulate your data and take sections of it to train your machine learning algorithm. It's a very handy tool in the data science and machine learning world. Next, we'll be using NumPy very briefly. And NumPy is just a library for representing matrices and performing operations on them. Think matrix multiplication, transpose, and that sort of thing. Next, we'll have matplotlib, which is a library for plotting graphs in Python. And last but not least, we have SciKitLearn, which is a machine learning library, and it implements many machine learning algorithms, and it lets you fit your machine learning algorithms to your data. So let's start off by importing our data and setting up our API. Start off by installing Spotify in your environment and get yourself a Spotify API ID and secret key. You can find instructions online or find them right here. I've got mine hidden behind this cell, which I'll run. And indeed, if you were following along with the tutorial, you'll want to set your client ID right here, your client secret. This is all the imports for the libraries and tools that we'll be using. And this is the line just to set up Spotify. So it tells Spotify who this person that is requesting information is, and that's through your client ID and client secret. Just make sure to run that cell. Now let's move on to retrieving your data set. We start off by setting a list of features, audio features that we'll be using to classify our tracks and our music. And this is data provided by Spotify. So Spotify knows these metrics that they give out to developers: acousticness, danceability, energy, loudness. All of these variables are variables that will be useful in evaluating genres and telling genres apart. And we'll also be defining a method called getPlaylist, where it'll take a Spotify link and it'll give you three lists of track IDs, track names, and features. So let's start populating this function. First, we'll want to actually get our playlist from Spotify. And you do this by typing in the following. We'll tell it our Spotify playlist link, and it'll give us some information about our playlist. And the main information that we want over here is the size of the playlist. We want to know how many items we're going to be processing. The total will give us the total size of the playlist. Next, we'll want to initialize the lists that we'll be using to keep track of our data. We'll be having a track IDs list, track names list. We're starting off as empty, and a features list. And a thing to note about Spotify is that it can only take 100 tracks at a time. So if we have a playlist of maybe 300, 400, 500, we'll need to process that in batches of 100 tracks. So we'll be using this variable offset to keep track of that. And we'll keep processing while offset is less than the total size of our playlist. Now let's start off with actually getting some information. We'll be using a HTTP request to get a response. Name is equal to response name. Rather, okay. Response name is equal to a playlist items. We'll give it our playlist ID, tell it what playlist we're looking for. And Spotify has a lot of data, so we're going to tell it more specifically what fields we're looking for. We're looking for the track name, and we'll give it our offset as well. We want to do a similar response get operation for the IDs. Now that we've got our batch of items, we have a batch of maximum size 100. This is just a list of names. We'll have another batch of the same size of IDs. Next, we'll want to iterate over that batch in order to get each track name inside that batch. So we'll use a counter is equal to 0. We'll just set the total length to the response name length. That's just because suppose your playlist is 150 tracks. You'll have a batch of 100, total length will be 100, and then the next batch will be total length of 50. So we want to keep that in mind. Next, we want to get the individual names. Over here, we get the IDs as well. Again, Spotify gives us a lot of data, and we really only want our name and ID at this stage over here. Now we'll just do a check in case the song gets taken off of Spotify. So we don't have any erroneous data in our data set. And we'll add our name and ID to track names and track IDs respectively. And then from there, we'll want to increase the count, increment by 1. And it'll go through each name and ID in these two lists. And we got the name and ID, but we also want the audio features that we'll be training on. And Spotify allows you to do that in an entirely different method. So let's get those audio features. So we're getting a batch of features going from our offset to our offset plus the final count of this loop. And that'll give us the batch of size equal to this entire loop. Now, this is only one batch, and we want to add it to our total feature list. So let's go ahead and do that. So you'll notice over here, batch features at 0 is feature 1, feature 2, feature 3, 4, track 0. So when we're adding to our features, we'll want to add a list. Let's say y is equal to 0. So for track 0, you want to create a list of all your features. And then for each y, we add that to our feature list over here. And then at the end, you just increment the offset by 100. And after all this, we'll be returning our track IDs, track name, and feature. Make sure to run that by clicking Shift-Enter. And over here, we're just running a sanity test to make sure that our track IDs, track names, and features are all coming out as expected. So you see over here, we're just listing out the first 5 elements and track IDs. Those are the IDs over there. The track names, a bit more readable. We have 5 hip hop tracks. And the features, this is the list of features from above. You know, the acousticness, the danceability, the energy, all that fun stuff. Next, you'll want to create a data frame. Python lists are great, but for data science and machine learning, a data frame works far, far better for our purposes to take a look at the data and understand it. And this method actually uses our get playlist method from above. Similarly to above, it takes a playlist link as its argument. You may have noticed with the features matrix, if we scroll on up over here, batch features at 0 is feature 1, feature 2, feature 3. But we want to organize our data frame such that one column has feature 1 for all of our tracks. The next column has feature 2 for all tracks. And so we'll be using NumPy to actually transpose our matrix to get it in that form. We'll transpose the NumPy array. And as an intermediary step, we're going to make 2 dictionaries. These dictionaries work to define the columns for pandas. We'll have a column for names. We'll just input all the track names over there. Then we'll have a column for IDs. Similarly, we'll put in the track IDs right there. Now for our features, this is a n by 12 matrix, where n is the size of the playlist, and 12 is the number of features. So let's create another dictionary for just that. We'll be setting the column name to the feature list, which we defined above. So the column name can be acousticness, danceability, energy, so on and so forth. The transpose will have the column vector for each one of those fields. We'll be creating a dictionary for that. Now we have two different dictionaries, but we really want to put that into one data frame. So let's go ahead and merge the dictionaries. And then finally return the pandas data frame of our data. Now, in addition to creating the data frame, which I'll show right here with hip hop head, it'll sanity check and make sure that all the values are here. You have the name, the acousticness, danceability, so on and so forth. We want to be training our machine learning algorithm. So we downloaded a hip hop playlist, but we need to tell our machine learning algorithm, hey, this is hip hop. We're just going to tell it what the label is. If we run this now, we'll want to label our hip hop data. Let's do it right here. We're saying for column target, setting all the values equal to hip hop. Now you'll notice over here, we don't have a column target, but Pandas knows that if we're setting a value for a column, it just needs to add a new one and set all the values to hip hop. So go ahead and run that. Take a look at the head again, and here is the target. All of these songs are classified as hip hop. Now that we have a way of retrieving a lot of data for our playlists, let's take a look at the genres that we will be classifying our music under. We have the hip hop genre. I also have an oldies genre, anime genre, and a classical genre. We can go ahead and grab the playlist for each one of these. Notice that we're setting the target as well. Target is oldies, target is anime, target is classical. We're telling it what each of these playlists looks like. And of course, feel free to sanity test oldies.head. It'll show the first batch. And this looks just fine. You have the anime playlist and classical. All looking good. Now we want to bring together these individual subsets into one unified data set. Because we labeled our data, it'll be fine for us to put it all together. We'll just be using pandas.concatenate hip hop, oldies, anime, classical. You can run a quick sanity check. You'll see that all the top ones are hip hop, and that's just because our first entry was hip hop. Next, we'll be defining a very small function for getting the numerical features. When training our Random Forest classifier, it's not useful for it to know the ID or the name of the song. Now, these are useful information for us. So let's go ahead and extract the numerical features. We'll be getting the data frame at feature list. Now remember feature list from before? Feature list contains all of the audio features that we're looking to classify based off. So we'll create and compile that method. And finally, we're at the section of training your Random Forest classifier with all this data that we worked hard to put together. A brief overview of a Random Forest classifier. It's a fantastic algorithm for classifying data. How it works is that it makes a lot of decision trees based on data points in your data set, and it creates many of these trees. When you have a lot of trees, it creates a forest. And together, they almost work in a democratic system of all of these different trees are taking in new data, and based on the data set that they've previously seen, they'll make a decision. And the decision that the most decision trees agree upon is the output for the random classifier. So first, let's get our data sets for the random classifier. We're getting our numerical features for X. And at Y, remember our classification is just the target over here. So we'll just need to get all data frame dot target. Of course, you take a look, Y dot head, hip hop is all the first. That's the same as our data frame back there. And X over here, you'll see it's all numerical values, all data that our machine learning algorithm would love to take a look at and classify based on. So now it's a good idea when performing machine learning to split up your data into a training set and a test set. The training set is the data that we'll use to train our machine learning algorithm. But in order to really understand how it performs, we want to throw at it similar type of data that it's seen before, but it's not the same. It's new data. It's just from a similar distribution. And so this X test will let us validate. It'll let us observe how well our algorithm performs. And when working with labeled data, of course, you want to split it on the target, the Y as well. This is the labels that we set for each value. We're using this method that we imported from SciKitLearn, train test split, X, Y, and we'll say that the test size is 20% of the overall data set. Now, it's important to keep in mind that train test split also shuffles around the values in X train, X test, and so on, so that the top isn't dominated by hip hop and then the bottom by classical. In addition, we'll want to create what's called a scaler. And this allows us to scale our data in order to make it easier for our machine learning algorithm to learn. You'll notice the ranges for this data is pretty immense. You have -3 over here, but only 0.1, not to mention the 0. I don't know how many zeros, 3. The ranges are very different. And the scalar will allow us to have a mean of 0 and a standard deviation of 1 for all of these values. So it'll make it easier for our classifier to learn the data. Next, you'll form a fit transform on X train. So we're creating a scalar to fit to X train, to fit to X train's mean and standard deviation. And our scalar will allow us to transform any subsequent data on the same transformation on X so that things remain consistent. And it'll output the X train scaled, which is the scaled version of X train. And we'll want to, once again, create a Pandas data frame for the scaled data. And we really want the columns of X to be the exact same. Let's run that. And let's just take a look at X train scaled. And notice that they're all values that are around the same range. They're all centered around 0, and the standard deviation is the same, but you'll see a couple outliers over here, over there. Now we want to see the part where the magic happens. The magic happens in the Random Forest Classifier. So let's create that classifier. Forest is equal to Random Forest Classifier. And this is where hyperparameters come into play. You'll see that there's a lot of parameters that we can play around with, but we'll keep it simple for today. We'll set our n estimators to 200. Set a max depth of 5. We've created a forest, but now we want to fit our forest to the training data over here. So let's do just that. We're giving it our scaled X, as you can see over here, and the labels for X so that it gets to learn what that data in X looks like. You can go ahead and run that. Just created a Random Forest Classifier. Let's take a look. Let's evaluate our forest. Remember, we want to apply the same scalar to any new data that we are putting into our forest. So notice that we made the scalar fit to X train, and we want to test it on X test. Let's scale it. Scalar.transform X test, our test set. Of course, let's evaluate it using Y test. You'll see we got a 92% accuracy rate, which is pretty incredible based on a couple random playlists on Spotify. This is just a method that we can use to take a look at how it predicts. So predict on playlist, you send it in a playlist link. This is the one that I sent it. It'll create the data frame, get the numerical features. It'll scale that new data. Then the forest will predict on the scaled data, and we can take a look at what its predictions are. You can see over here, I put in my personal playlist, and it's correctly identified. Africa is an oldie for sure. Stand By Me. All of these are correctly identified. And I implore you, take a look at what your playlist looks like by just throwing in a link over there and running it on the method. Now, I also want to take a look at how our forest performs on individual metrics. So let's make it predict, again, x.test. You got to scale that. Let it predict based on that. And it'll give us a report. And these numbers shows us how well it's done on each of the classifications. And you'll notice classical, it was able to get it right away. It knows exactly what classical looks like in the data. The anime as well, it performs very good. The oldies, not so much for whatever reason. Maybe the genres were a bit too wide-ranging in the oldies. The precision and recall are two metrics to measure your machine learning algorithm. And the F1 score is a sort of unification of these two. So really, this is what we want to look at. And it doesn't perform too bad on the oldies, but it could be better. Now that you've seen how we made classifications for each of these, take a look at what other genres you can throw at your random forest classifier. Maybe you can add techno or EDM or grunge or folk music. Whatever you want to add to your genre list, you can do just that by following the steps in this tutorial. You can, of course, predict on your own playlist and take a look at what it thinks your music looks like. Thank you so much for listening in and following along to this tutorial. I hope you learned a lot about using APIs, using these popular libraries in machine learning. I hope that you were able to get a good prediction on your own playlist. And I hope that you've had fun, most of all, in this tutorial. I hope that you come to more tutorials in the future, because this is a fantastic learning opportunity to get to know these technologies and tools that are essential to the data science field. Once again, thank you so much. And I hope you enjoyed. Thank you.